Good morning, class. Here's chapter 1, sequences, section 1.6, sequences and difference equations. One point six, sequence and difference equations summary. A sequence is a list of numbers written in a specific order, a sub 1 all the way to a sub n, first, second, nth terms of the sequence. Accordingly, a sub n is the general term, and n being the set of natural numbers, also known as positive integers, 1, 2, 3 to infinity. Recursive sequence, also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. The next term depends on knowing the previous one or previous ones. The format is a sub n plus 1 is f of a sub n. A couple of sequences we are familiar with, an arithmetic and geometric sequence. An arithmetic sequence, a sub 1 plus d, a sub 1 plus 2d, and this is the general form, a sub n plus n minus 1 times d, where the difference d, also known as distance between consecutive terms, is constant, can be defined by, we can write it a sub n plus 1 as a sub n plus d. This is recursively, meaning if I want a term, I go to the previous one and add a constant, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. So as you can notice here, 1, 5, 9, 13, we are adding 4. And so in each case, we are adding 4, which makes it an arithmetic sequence. Similarly, a geometric sequence, a sub 1 r, a sub 1 r squared, and the general term a sub 1 r to the power of n minus 1, where each term is r times the previous one, can be defined recursively by a sub n plus 1 equals r a sub n, meaning if you want a term, pick the previous one multiplied by r, or explicitly a sub n equals a sub 1 r to the power of n minus 1. Example, 1, 4, 16, 64. Notice we are multiplying by 4, in which case we are multiplying by 4 and r becomes 4. Again, reminding you, we had the summary, and we're going to repeat some of the definitions. A sequence is a list of numbers written in a specific order. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concept of sequences, the data and difference equation, the description of the mechanism of change. A sequence is a real valued function f, whose domain is the set of natural numbers, 1, 2, 3 to infinity. We use the notation a sub n to denote f of n. So the first one is a sub 1, the second term is a sub 2, the general term is a sub n. Let's look at a couple of examples. First, the easiest one, a sub n equals n. So replace the n with 1, you get a1 equals 1. Replace the n with 2, you get a2 is 2. And the rest of them, and we want 5 of them. So simply 1, 2, 3, 4, 5. We do the same thing here. B sub n is sine of n pi over 2. So sine of 1 pi over 2, that means pi over 2. 2 pi over 2, that means pi. 3 pi over 2, 4 pi over 2, that means 2 pi. And 5 pi over 2. So sine of those trigonometric functional values. So what are they equal to? So let's go back to geometry and trigonometry. Here's a circle centered at 0, 0 with the radius r, has the equation x squared plus y squared equals r squared. If the center is no longer at 0, 0, rather at h comma k, the formula becomes x minus h quantity squared plus y minus k quantity squared equals r squared. If the radius is the 1, this one is called a unit circle. So unit circle is the circle centered at the origin with radius being 1, 1 squared is 1, so this is called a unit circle. If we are dealing with a unit circle, make it a little bit larger so we can make it easier to see. This point has coordinates 1, 0, 0, 1, negative 1, 0, 0, negative 1. As far as trigonometry is concerned, when you have an angle in a standard position, that means the initial side is along the positive x-axis, then we have a 0 angle, 90 degree, this one makes a 90 degree angle, or pi over 2, 180, or pi, 180 degrees, and this one is 270 degrees, or 3 pi over 2, and a complete revolution is 360 degrees, takes us back to the 0, but it's 360 degrees. Those angles are called quadrantal angles because they are, the terminal side is along the positive or negative side of the x-axis, positive or negative side of the y-axis, and their trigonometric functions are easily calculated. So if we look at this one, the x is represented by cosine, and y is represented by sine. The reason is cosine of theta in general is the adjacent over the hypotenuse, whereas sine in general is the opposite over the hypotenuse. And what is the hypotenuse in the case of a unit circle? The hypotenuse has a value of r equals 1. So if the denominator is 1, it's just the numerator. So this becomes cosine, this becomes sine. So every point with coordinates x comma y on the unit circle has the equation x equals cosine, y equals sine. That being the case, we know this has coordinates 1, 0, so cosine of 0 is 1, sine of 0 is 0. So cosine 0 is 1, sine 0 is 0. So if you look at this one, obviously, cosine of pi over 2 is 0, sine of pi over 2 is 1. If you're looking at this point, okay, again, this one class pi over 2 and 90 degrees. This one, 180 or pi. Cosine of pi, negative 1. Sine of pi, 0. And this one, everybody, the angle is 270 degrees, or 3 pi over 2. Cosine is 0. Sine is negative 1. And in general, reminding you, sine of n pi is 0. Cosine of 2n plus 1 pi over 2 is also 0. So this is a piece of information from trigonometry. Therefore, we can easily find the values here. All right. Again, analytic geometry in combination with trigonometry, some basic trigonometric functions. What about this one? C sub n is n over 1 plus And so C sub 1 is 1 over 1 plus 1, or simply 1/2. If I want C sub 2, I put 2 over 1 plus 2, so that's 2/3. If I want C sub 3 is 3 over 1 plus 3, 3/4, and I have the rest of it. D sub n equals the digit in the nth decimal place of pi. Please understand, pi is not equal to 3.14. It is approximated by that, and it's equal to 3.14159, and it continues indefinitely. So therefore, this is the first digit. The first decimal place is 1. This one is second one, 4, and you can see the rest of it. Example 2, given the general term, find the first 5 terms of the sequence A sub n equals 2 to the power of n minus 4. So obviously, the first one would be 2 to the power of 1 minus 4, which is 2 minus 4, which is negative 2. The second one would be 2 squared minus 4, which is 0. The third one would be 2 cubed, which is 8 minus 4, equals 4. And I'm going to leave these two for you as practice to double check to make sure we have them right. 12 and 28. Find the formulas for the general term of A sub n of the sequence, and sometimes it's difficult to find it. It's easy to figure out what happens in this case. From 5 to 8 to 11, you're simply adding. Number 3, so you have an arithmetic sequence with the D, or difference of 3. So we have the first term, A sub 1 as 5, D as 3. We know the general formula, A sub n equals A sub 1 plus D times n minus 1. We're going to replace it. We're going to replace A sub 1 with 5 and D with 3. Distribute. We get 5 plus 3n minus 3. And these two add up to 2. The final answer is 3n plus 2. And you must check. If n is 1, we get 5. If n is 2, we get 8. If n is 3, we get 11. You have to check your work always. It takes a split second to make sure we've come up with the correct answer. By inspection, we noticed this one was an arithmetic sequence. By inspection, we noticed this is a geometric sequence with the ratio of negative 1/3, everybody. A1 is 1. If you multiply by negative 1/3, you get negative 1/3, again 1 over 9, so on and so forth, okay? So this is the first term, and R is -1 there. This is by inspection. So A sub n is A sub 1 R to the power of n minus 1. Okay, so that's by inspection. We are going to plug in, replace the A sub 1 with 1 or with -1/3. You can leave it as that. However, we have what is called an alternating sequence. So when the sign changes, we separate the -1. First of all, this has no bearing. So -1 to this power, 1/3 to this power. And you have to realize for any alternating sign, either we have -1 to the power of n over here or -1 to the power of n minus 1. In some texts, they may use n plus 1. It works exactly the same. Notice if n is 1, -1 to the power of 1 becomes -1. So the first term is negative. So this is used for a sequence that starts with a negative and then alternates. Whereas this one, if I change the n to 1, I get -1 to the power of 0, which makes it +1. And I'm just looking at the sign. So how do we check? Let's plug in 1 here and reminding everyone a to the power of 0 equals 1. So if I plug in 1 here, -1 to the power of 1 minus 1 over 0, 1/3 to the power of -1 over 0. This is 1, that's the first term. I highly recommend you try the second and the third one. You must always check your work. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one. And it may not always be possible to determine the general term of the sequence algebraically. We've discussed that before. A difference equation or recursive sequence is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is real valued function. A solution is a sequence a sub 1, a sub 2 all the way to a sub n, satisfying the given difference equation. One of the famous ones is Fibonacci sequence. The original one starts with 1. You may start from anywhere as long as you follow this f sub n, because f sub n minus 1 plus f sub n minus 2, meaning if you want a term, pick the previous one and the one before that and add them up. So 1 and 1 is to begin with, of course, n larger than or equal to 3. And then you add them up. 1 and 1 is 2, 1 and 2 is 3, so on and so forth. So if I want the next term, for example, I'm going to add these two. And I get 34. If I want the next one, I add 21 and 34. I get 55. So that's how we get it. And it happens in the nature a lot. Example, in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. So you have the first year 1, the second year also 1, then they add up to 2, and the next one, 1 and 2 is 3, the next one, 2 and 3 is 5, and so on. Find the first 6 terms of the recursive sequence. A sub 1 is 6, a sub n plus 1 is a sub n over n. Since we have the first one, we are looking for the second one. So what is the formula for a sub 2? According to this, and I want to make sure that you understand how easy it is. So all you have to do is say, okay, this is 2, everybody. If n plus 2 is 2, n becomes 1, right? So a sub 1 over 1, which means 6 over 1, which is 6. What about a sub 3? I want to make sure that we understand that a sub 3. So if n plus 1 is 3, That means n must be 2. So a sub 2 over 2, which is 6 over 2, which is 3. Now, if I want the next one, a sub 4, now n plus 1 is 4, which makes n 3. So I have a sub 3 over 3. So this number divided by 3 is 1. And you can figure out the next one, a sub 5 and a sub 6 on your own. A sub 1 is given as 1, a sub 2 is given as 2, and a sub n plus 2 is a sub n plus 1 plus 2 a sub n. Please understand the meaning of this. If I want any term, I pick the previous one, and then 2 times the one before. So I have a sub 1 and a sub 2. So if I want a sub 3, if I want this one to be 3, I'll go to the previous one, which is 2, a sub 2, and the one before that, a sub 1, 2 times a sub. That's the meaning of it. One way to look at it, you can say n plus 2 is 3, which makes n1, and you replace the n accordingly. So that, simply put, means 2 plus 2 times 1, they add up to 4. Now, it may be easier to look at this one. A sub 3 is a sub 2 plus 2 a sub 1. So a sub 4 must be a sub 3 plus 2 a sub 2. That's one way to look at it. Or just follow the formula. Understand the formula. If you want a term, go before that. So a sub 4, I go before that, a sub 3. And then the one before that, a sub 2, multiplied by 2. So this is 4. 2 times 2, 4 and 4, 8. The next one is 5. So what is a sub 5? A sub 4 plus 2 a sub 3. So a sub 5 is a sub 4 plus 2 a sub 3. So a sub 4 is 8. 2 times a sub 3, which is 4, gives us total of 16. I leave it for you to figure out a6 on your own. So it's pretty straightforward. I hope everybody's okay with that. A sub n plus 1 is 2, a sub n minus 4, and a sub 1 is 3. Meaning, if you want any term, a sub n plus 1, go to the previous one, multiplied by 2 minus 4. So if I want a sub 2, just change this one to 2. If I want a sub 2, then n plus 1 must be 2, which means n must be 1. So 2a sub 1 minus 4. 2 times 3 minus 4 is 2. It may be easier to look at this one. A sub 2 is 2a sub 1 minus 4. So a sub 3 is 2a sub 2 minus 4. Rather than looking at this one, I don't know, you decide. But it's very straightforward. You want a sub 3, 2 times the previous one, minus 4. 2 times 2, 4 minus 4 is 0. So if I want a sub 4, so I want a sub 4, that means n plus 1 is 4. I want 2a sub 3 minus 4, which makes it 2 times 0 is 0, minus 4 is minus 4. Okay. Suppose C sub t is the concentration of a drug in the bloodstream at time t. A, which is the amount of inflow, is the concentration of the drug that is administered at each time step. So time step, like every hour, every 4 hours, every 12 hours, every day, you name it. That's the meaning of time step. And K is the fraction, the portion, percentage of the drug that is gone, is absorbed in a time step. What is the recursion that models the dynamics of drug concentration? So normally we use n, so I want to go with n, but I'm going to come back to this. N sub t plus 1 is n sub t. So if you want the next one, you pick the previous one, you add the amount of inflow, and then whatever comes out, minus outflow. So to understand the concept, we are giving medication to a patient. A patient has some medication in the body. That is the previous one. We are adding so much, the inflow, and we are taking some out. So first of all, we're going to change this to C sub t plus 1. This becomes C sub t, inflow plus A. But what is the outflow? K is the fraction that is gone. So K times C sub t. Please understand that this outflow is the portion that is absorbed by the body, that is gone. In other words, the amount of medication you give to a patient because of the time step is not going to stay constant. It's going to diminish. By how much? K. Now, if K is, let's say, 10%, that means 90% remains. If it's 70%, then 30% remains. That's why I want to combine these two. If you combine these two by taking C sub t out, you get this formula, and the meaning of 1 minus K, the complementary event, is if K, the portion is gone, for example, 2/3 is gone, 1/3 is left. If the initial concentration is C sub 0 equals 120 micrograms per milliliter and A equals 80 micrograms per milliliter and K is 1/2, plot some points on the graph of C sub t. So what is given? C sub 0, A, and K. First, let's write that. Those are the given, everybody. And now we go to this formula and replace the K with 1/2, A with 80. 1 minus 1/2 is 1/2. So that becomes the general formula. C sub t plus 1 is half of C sub t plus 80, meaning anytime you want to see how much medication we have, get half of the previous one and add 80. Now, normally, in the case of patients, C sub 0 is 0. I want you to know that. But in this case, C sub 0 is given. So that means the next one is C sub 1. And C sub 1 is half of that, half of C sub 0 plus 80. So half of 120, 60 plus 80 is 140 micrograms per milliliter. The next one is C sub 2. C sub 2 is half of that, half of C sub 1 plus 80. So half of that, 70 and 80, 150. The next one is C sub 3. According to this formula again, C sub 3 is half of C sub 2 plus 80, which means half of 150. 75 plus 80, 155. And this trend continues. So what is it that we are getting to? This is important. If you plot the points, the idea is that because of the time step and a portion of a medication is being absorbed, This will not go indefinitely up because it can be more harmful to the patient. So at some point it plateaus and it becomes what we call horizontal asymptote. And the formula is A over K. And I'm going to, first of all, calculate that for you. For this question, C sub T is the amount of inflow, which is AD divided by K, which is 1/2, and we get 160, which means because of this time step, no matter how much you continue, it will never ever go beyond that, and it has been calculated to be safe for the patient. Now, how do we get to A over K? I'm going to show you this, and we're going to discuss that further in the next section. So the proof is as follows. We know this formula. That's the formula. We are going to assume the limit exists. That means at some point it doesn't change. So the limit of C sub T plus 1 as T goes to infinity, and the limit of C sub T as T goes to infinity becomes the same thing. X, Y, Z, L. We use L for the limit. You can use any variable you want here. Let's take a limit of this of both sides because this is equal to that. The limit of both sides must be the same. Limit of the left as t approaches infinity is the limit of the right as t approaches infinity. And we said this limit, we can replace it with L. This limit for C sub t, we can also replace it with L. So this becomes L. This becomes L times 1 minus K plus L. And this one, everybody, the right side equals L minus LK plus A. You can drop the L from both sides, you get 0. And of course, L becomes A over K. That's what we proved here, okay? So the bottom line is, the limit is A over K, in this case, AD over 1/2 or 160, and that is going to be the amount that is not harmful for the patient.